Yes, good morning, students. Mark your attendance. And first group, share
Yes, sir.
presentation. Share your presentation.
Yes, sir.
Screen is visible, sir.
Yeah, it is visible.
Can we start?
Okay, you can start.
First of all, good morning, one and all. I am Shruti Sunilpote is here with my team to present the topic shared memory multiprocessor, uh, guided by Professor Anand Barbin sir. Now Shreya will be telling you about the presentation topic.
Maximize your screen. Go to the presentation mode.
Sir, it is in mobile.
Mm, is it on the slide? Uh,
So we can zoom it.
See, there is an option there. Present option is there. That cup symbol. Is that becoming full screen? There are three different tools there. So four. So uh, left to the three dots, there is redo or undo, and beside that there is symbol.
Sir, there is no any option.
Okay, let it be.
Good morning, friends. I am Shreya Purushottam Valte. So, friends, in our team there are 6 members, in which Shruti will be telling you about the basics of multiprocessor. Vaishnavi will explain what is shared memory multiprocessor. Then Sakshi will explain non-uniform memory access. Maheshwari will explain about uniform memory access. I will be explaining about and cache-only memory access. And lastly, Pradnya will tell you about advantages, disadvantages, and applications of shared memory multiprocessor. Now, Shruti will tell you about multiprocessors. Shruti.
So, friend, what is multiprocessor and why we need the multiprocessor? Multiprocessor is a system. There are more than one system are enclosed, and we need a multiprocessor because we increase our speed by multiprocessor. Uh, if in our computer we contain more than one multiprocessor, then obviously speed of CPU is increased. There are two types of multiprocessor. First is shared memory multiprocessor and another is distributed memory multiprocessor. And there are some advantages of multiprocessor and disadvantages. First advantages is increased reliability, cost saving, third is battery efficient, and disadvantages is more complex structure and large main memory, because processor is always come from main memory. Now Vaishnavi telling about the shared memory multiprocessor.
Good morning, friends. So I will explain you what is shared memory multiprocessor. A system with multiple CPU sharing the same main memory is called multiprocessor. In a multiprocessor system, All processes on the various CPU share a unique logical address space, which is mapped on a physical memory that can be distributed among the processes. Each process can read and write a data item simply using load, and stored operation is thought shared memory. It is the hardware that makes all CPU access and use the same main memory. Then next slide. Uh, then this is the basic structure of memory multiprocessor memory. Uh, since all CPU share the address space, only a single instance of the operating system is required. When a process terminates or goes into a wait state for whichever reason, the OS look in the process table for another process to be dispatched to the ideal CPU. On the contrary, in a system with a shared memory, each CPU must have its own copy on CPU of the operating system, and processes can only communicate it through message passing. The basic issue in a shared memory itself, since the larger the number of processes involved, the more difficult to work on memory efficiently. And the distinct feature in multiprocessor system is load balancing. Then the types of shared memory multiprocessor is: first is a UMA, stands for Uniform Memory Access. Second is NUMA, stands for Non-Uniform Memory Access. And third is COMA, stands for Cache and Memory Access. Now Maheshwari will tell you about first type of shared memory multiprocessor. So Maheshwari.
Good morning, friends. Good morning, friends. I am coming to the first point of shared memory access. That is, that is the uniform memory access, which is also short in UMA. In an uniform memory access architecture, access time to a memory location is independent of which processor makes the request or which memory chips contains the transparent data. So, physical memory uniformly shared by all processors with equal access time to all the words. So, there have a shared memory and all the processor have a accessing the memory. So, equal access of time uh, shared by processor for any particular time. Then uniform memory access computer architecture are often constrained with non-uniform memory access architecture. Next, in the uniform memory access architecture, each processor may use a private cache. Peripheral are also shared in some fashion, and peripheral it is also in input output can be shared. Then last point is application of uniform memory access. The uniform memory access model is suitable for general purpose and time sharing application by multiple users. Then next, it is used in speed up the execution of single large programming type critical application. Then next is Sakshi tell you about the non-uniform memory access.
Good morning. Now, non second type of share memory. This is non-uniform memory access. In short, NUMA. NUMA is a computer design used in multiprocessing. This is one of the type of share memory multiprocessor. That means under NUMA, a processor can access its own local memory, which faster than non-local memory. This system have a shared logical address space, but the physical memory is distributed among CPUs. That's why in this system, the access time data is depend on the data position. That's why it is also called as distributed shared memory. Now, next, uh, the catch point is Shreya.
Cache only memory access, comma. So friends, here C stands for catch, O stands for only, M stands for memory, and A stands for architecture, which forms comma. Comma is a type of catch coherent non-uniform memory access. Since the comma hardware automatically replaces the data and migrates it to the memory module of the node that is currently accessing it. Comma increases the chance of data being available locally. Data have no specific permanent location in cache-only memory access. There is no specific memory address where they stay. Data can migrate and can be replaced in the various memory banks of central main memory. In comma model, processors have cache memory, the cache taken together from the global address space.i. Initially, data placement is not critical as cache blocks will eventually migrate to where they are needed. Multiprocessors plus cache memory forms comma. Now Pradnya will be telling you about advantages, disadvantages and application. Pradnya.
Good morning, friends. Advantages of shared memory multiprocessor are as follows. First point is system scalable, means when it has the capacity to accommodate a greater amount of usage. Then it hides the message passing, do not explicitly specific sending message between processing. Then it can as simple extension to sequential programming. Then last point is it is increased reliability. Then disadvantages of shared memory multiprocessor are as follows. It may incur a performance penalty. Then it must provide for protection against simultaneous access to shared data in bracket loop. Then little program control over actual message being generated. Then its system are expensive. Then shared memory multiprocessor are required complex operating system. Then then last point is a large main memory required. Then the application of shared memory multiprocessor are as follows. It allows efficient work with a large files without mapping the whole file into memory. And then second point is if several process is use the same file mapping to create mapped regions of a file, each process views contain identical copies of the file on disk. Thank you.
This is a reference of ninth edition William Stabling's books on computer and data communication, Google ebook co-Patterson PDF. And thank you so much, all of you.
So friends, this was all about shared memory multiprocessor. Thank you.
Yes, questions on this, students? Yes, one by one you can answer the questions. The first question is, shared memory is used in multi-processors or multi-computers. Yes, got the question. Whether shared memory is used in multi-processor systems or multi-computer systems.
Multiprocessor.
Sir.
Okay. So the one who has already given answer will not give answer. How is the communication in shared memory processors? How is the communication? Yes. Is it through message passing?
The processor shares a common memory address space and communicates with each other via memory.
Okay. Whether communication is faster in shared memory multiprocessors or in message passing. Shared memory communication is faster or message communication is faster.
Message communication is first.
Message communication is faster than shared memory communication. Yes.
The shared memory is maximum.
Shared memory communication is faster because it is through the common shared memory on the bus, whereas the message it goes across the network and there will be delay on the network, and that is why the that is uh, faster. Okay, memory shared memory is faster. Okay, next group.
Yes,
Is
sir.
the next group ready?
Yes, sir. Yes, sir.
Share your slides.
Yes, sir. Sir, is screen visible?
Yes, it is visible.
Yes, sir.
Good morning, respected teacher and friends. We are a group of four students from roll number 25 to 28. Hello, sir. I am audible.
Yes, yes, go ahead. You are audible.
Yes, yes, sir. Thank you, sir. Sir, we are the group of four students from 25 roll number 25 to 28. On behalf of the self-learning process, we are going to present on the presentation of cluster guided by Barvin sir. So I request to Tejas to introduce the cluster.
Next slide.
Slide, sir.
Siddharth, next slide. An important and relatively recent developed computer system design is cluster. Cluster is similar to symmetric multiprocessing, which provides high performance and high availability. Cluster is a group of interconnected computers working together that can create an illusion of being on machine. It is particularly attractive for server applications. Means it is widely used in server applications. Benefits of cluster use of clusters. Next. Absolute scalability. It is possible to create a large cluster. A cluster can have 10 hundreds or even thousands of machines, each of which is a multiprocessor. Incremental scalability. A cluster is a configured in such way that it is possible to add a new system to the cluster in small increments. Next slide. High availability. Because each node is a cluster in a stand-alone computer, the failure of nodes does not mean a loss of service. Superior price. It is possible to put together a cluster with equal or great computing power than a single large machine at lower cost. From here, Bhushan will continue.
Now second, there are the some methods of cluster. There are the five methods of cluster. First, passive standby. Passive standby is a secondary server take over it case of primary server failure. Its benefit is it is easy to implemented, but it has a highly costed. Second is active secondary, active secondary method. The secondary server is also used for processing different tasks. It has benefit to reduce the cost of secondary server. Third is a separate server. Separate server have their own disk. Have own disk. Data is continuously passes from primary or copied from primary to secondary server. It has high availability. Fourth method is a server connected to the disk. Server are capable to the same disk, but each server has own disk. If the one server is get failed or it get any issue, then the disks are taken over the other server. Its benefit is reduce the network and server overhead due to the elimination of copying operations. And last method is a server share disk. Server share disk has multiple servers. It there are multiple servers simultaneously share access to the disk. It has a benefits as low network server and server overhead, reduce risk to downtime caused by disk failure. Now the limitations of servers. Next slide, Siddharth. Hello, Siddharth.
Yes, is there any problem in his connection?
Yes, he has internet connection problem.
I think internet connection problem.
Bhushan, you please.
Can I present, sir? Just
Yes,
a minute.
if you have copy, then present it.
Yes, yes. Just a minute. Sir, is it visible?
My connection was disconnected.
No, no, no problem. I have shared it.
It is visible. You can go to the
Okay.
slide tab.
So these are the methods, and these are the limitations of cluster method. The passive standby method has a limitation as it is highly cost because because the secondary server is unavailable for processing other tasks. The active secondary method has a limitation as it increase the complexity of the servers. The separate server has the limitation as high network and server overhead due to copying operation from one another. The fourth method is server connected to the disk. It has limitation as it requires it requires mirroring and rate technology to compensate for risk of disk failure. And the fifth, server share disk requires loop manager software. It requires lock manager software, usually use disk mining or rate technology. Now, yeah, from here, Akshay will be explaining.
Good morning, one and all. Bhushan slide.
Yes, is it visible? Operating system design.
No.
Which slide is visible?
Limitations.
No, just a minute. Now which?
No. Still there is limitations
Yes,
left.
now it is visible.
Okay.
Just a minute.
Good morning, one and all. I will be explaining about operating system design issues. In operating system design issues, there are main three issues. failure management, load balancing, and parallel computations. In failure management, two approaches can be taken to dealing with failures. The first one is highly available clusters, and second one is fault tolerant clusters. With the help of these two approaches, failures are managed by a cluster. A highly available cluster offers a high probability that all resources will be in service. And in fault tolerant cluster, it ensures that all resources are always available. This is achieved by the use of shared disks and mechanisms. Next slide. In load balancing, a cluster requires an effective capability for balancing the load among available computers. The cluster must be incrementally scalable. And the third issue is parallelizing computations. Effective use of a cluster requires executing software from a single application such as parallelizing compiler, parallelizing application, and parametric computation. In parallelizing compiler, at compile time, it determines which parts of an application can be executed in parallel. And in parallelizing applications, in this approach, the programmer writes the application from the outset to run on a cluster and uses the message passing to move data. And the last one is parametric computations. If the essence of the application is program that must be executed in larger number of times with different set of starting conditions or parameters, one of its example is stimulation model. Now Siddharth will explain about cluster computer architecture.
Good morning, friends. I am Siddharth. Continuing the further representation with the application of cluster and having a look over what is cluster. Bhushan, please change the slide.
Is it not visible? I have
No,
changed it. What happened? Now, which is slide?
no, it is not visible.
Stop presenting and again present.
Okay, okay, sir. Just a
Okay.
minute. Now, is it visible?
Yes, yes, it's visible.
Just a minute. Okay.
So, as we introduce about what is cluster, cluster is the group of computers, and each computer is known as a node, and which perform the particular task and several tasks. So, one of its application is the blade server. So, it is one of the common application of a cluster. So, blade server is a server architecture. It means that there are many servers which are interconnected with each other and form a single architecture. That is known as a blade server. In that blade server, several servers are interconnected, and each server is known as a blades. And this blade server perform the different tasks and work as a cluster. Now, these blade server are mostly used in data centers such as of multimedia. Bhushan, please change the slide. Uh, So it is the diagram of the blade server. So here what is happening? Here are multiple blade computers which act as a blade server. So each blade computer is connected with uh, different blade computers by means of Ethernet switch. So what happened basically in cluster? The different computers or PCs are interconnected by means of fastnet LAN or hardware switches. So in blade server, the different blade computers are connected with each other by means of Ethernet switch. So each blade server, that is each blade computer have capability of 10 Gbps, which is very high, and it provide the high trafficking of multimedia trafficking. Means lots of information can be shared in a single blades computer server, and ether switches are used here uh, because for the purpose of interconnection of different blade computers with each other. This Ethernet switch have capability of 100 Gbps. Also, we can increase as we want, like here n into 100 Gbps. And this Ethernet switch provide a massive bandwidth of 100 Gbps. And this massive bandwidth help us to give large flexibility for trafficking of massive information in a minimum time. And these blade server are used in multimedia field, and it is very dominating over the single machine servers. Please change the slide. Now here is the cluster computer architecture, like how the cluster look like. So as we know that what is the cluster? Cluster is the group of different computer which are connected with each other. Now what happened here? These are known as PC organization, PC workstation, PC. There are different PC workstation, PC workstation or computers. These PC workstations or computer are connected with high-speed network or hardware switches. Like in Blade server, the Blade computers are connected with hardware switches, that is Ethernet switch. They can be also connected with high-speed network. Now what happened? Each computer is connected with high-speed LAN and or high-speed network and hardware switch perform a massive operations, and this is known as a cluster computer architecture. But still we cannot access this, because for accessing this there must be installation of software in each computer or PC or workstation with a cluster middleware software. This cluster middleware software provides the single system image and availability of infrastructure. It means that when we install the cluster middleware software in each PC and workstation or computer, what happened at that time, it gives access to this infrastructure. Means what is infrastructure? This cluster connected with each other, computers are connected with each other, so we can perform different tasks even though this PC and different computers are connected with each other by means of cluster middleware. Now we can perform sequential application, parallel application. What is sequential application? Sequential application means first of all, many application will be run, but first application will be run after completion of its task. Second application will be run after completion of its task. Third application in run. In this way, the sequential application can be run through this cluster. Also, the parallel application can also be run, like many different application at a time. We can run and complete their task by means of parallel programming environment. So the cluster computer architecture is dominating over single architecture. Like what happened, cluster computer architecture gives us advantages of it provide a highly improved system management. Like even though in some kind of cases if one PC or workstation get failed, so it will not we do not have any kind of threat of information loss, as this work PCs and workstation are connected with each other. And also it are very cheap. It is very cheap rather than having a single machine servers or architecture. And it provide improved management. Like if you wanted to add a new PC, a new workstation or computer, even though a big another cluster in a cluster, we can easily add it without affecting the work of another clusters or PCs on workstation. So in this way, the cluster computer architecture is dominating over the single computer architectures, and it also provides flexibility to the computer architecture. Next slide. So in this way, we have discussed about the clusters. So reference is taken from the ebook of Computer Organization and Architecture, Designing for Performance, 9th edition by William Stalling. Thank you.
Thank you, sir.
Yes, other students, questions, ask questions. Yes, no questions. Yes, can you tell example of some cluster-based computer system?
Sir, blade servers, which are used
Uh,
in
any
multi field.
any existing system which is cluster-based, popular system?
Sir,
Okay, what is a blade?
IB,
Hmm?
IBM Oracle is example of cluster.
No, I wanted to know the system that is implemented, not the hardware. Okay. Uh, one more group is there, no?
Yes, yes, sir.
Oh. So let
Can I share the screen, sir?
share your screen.
Okay, sir. Sir, screen is visible, sir.
Yes, yes, visible. Go ahead.
Okay, sir. Thank you. Good morning, everyone. I am Akash Devari. We are a group of five students from roll number 29 to 33. We are here to present you about self-learning seminar on the topic of message passing multiprocessor. So we will firstly start with introduction. In introduction, we have learned about IPCs, which are inter-process communications, in which program in execution for the communication of two different processes running on two different systems. There is need of mechanism, and this mechanism is nothing but inter-process communication, IPC. It is mainly of two methods: shared memory approach and message passing approach. In shared memory, it has a common memory area that is accessible to all process involved. This process shows about the shared memory approach, in which two processors are interchanged with shared memory. In message passing approaches are systems provide alternative methods for communication and movement of data among multiprocessor compared to shared memory multiprocessor systems. Uh, a message passing system typically combines local memory and processor at each node of the interconnection network as shown in diagram. Now I will hand over to Sridhar.
So, hello, good morning everyone. Message passing processor has been done, and point is as follows. Message passing is a subsystem of DOS provides a set of message IPS protocol. Second one, it is done by shielding of details. Third one, enables processors to communicate by exchanging messages. Fourth one, allows to be written in simple primitives like send and receive. Fifth one, it serves is an infrastructure for building other high-level IPC systems. And I will hand over to Prashant.
Okay, thank you, Sridhar. Good morning, everyone. Uh, Now I will be talking about message exchange by multiprocessors. Okay. Akash have shared. Besides the memory not being shared among the multiprocessors, another difference between the shared memory MMID and message passing MMID multiprocessor is the information sent through the interconnection network. Shared memory information sent in a shared memory MMID are data items between one CPU and one memory module. Two CPUs communicates with each other by writing or reading a value to or from a agreed location in the shared memory. Therefore, the data items transmitted through the interconnection network is small and fixed. In contrast, message passing MMID information sent in message passing MMID are data items between one CPU and another CPU. Two computers in a message passing MMID IMD communicates with each other by sending a message that contains sender's ID of the sending computer, receiver's ID, that is ID of the receiving computer. Message. The message sent is usually large and of variable size because there is a lot of overhead to send a single message. Now I will hand over to Ajay. Thank you.
Good morning. So I'm
Hello, Ajay.
He is not audible.
Sir, actually, he is in the village and there is no proper internet connection for him. Can I
Uh,
continue with it, sir?
okay.
Okay, sir. We will see now communication processing in message passing multiprocessor. In addition to performing computation, every processor in a message passing MIMD is also a router. A router is a which contains program plus CPU, then a forward message to its destination. Although routing is a complex problem, it is very trivial in message passing EMI because the interconnection network is very simple and regular. We will look at some commonly used interconnection networks for message passing MMD. Sir, desirable features of good message passing systems are simplicity, uniform semantics, efficiency, reliability, correctness, and ordering delivery. Now I will hand over to Shubham. Shubham, please continue.
Now at the end, the advantages and disadvantages of message passing multiprocessors. Firstly, the advantages of message passing models are message passing models is much easier to implement than the shared memory models. It is easier to build parallel hardwares using message passing models as it is quick, tolerant of higher communication latencies. Now the disadvantages of models. The message passing models has slower communication than the shared memory models because the connection setup is take time. Now the references we have taken the reference from the book Computer Organization and Architecture Design for Performances, which is ninth edition of the book by William Stallings, and the Google is the last reference. Okay. Thank you.
Yes, other students, questions on this? ask questions. Yes, no one is asking question from your class. About the attendance, has everyone marked the attendance?
No, sir, not yet.
Uh, you can mark your attendance. It is already enabled.
Okay, sir.
So today three groups have presented self-learning seminars, and uh, they have presented very well. Slides were prepared very good, and purposely this particular activity is uh, conducted to encourage the self-learning. And all the three groups they have presented nicely. So in every semester you will be having this particular activity, and a small part of the topic you will be given for the presentation. Though this is compulsory activity, you should not limit your self learning to the topic you are given, but you should extend to the topic of your interest, the topic which are important and beyond the syllabus, or even if they are in the syllabus, but somehow your teacher may not be able to go into the details of certain topics. So in such cases, you are supposed to do self learning, uh, and it will be for lifelong. Okay, so you will be keep learning for your life, and for that purpose your self learning capabilities should improve. Okay. So good presentations by all students. We shall stop here today.
Thank you,
Okay.
sir.